Good afternoon, everybody. This class is the final class we'll be considering on roots of equations. So we'll be considering finding the roots with software packages. Then we'll be considering Excel and using MATLAB. So for instance, if we want to locate the roots of x of this function x minus cos x. We discussed in the previous lessons that we can make use of the graphical approach and we can use Excel. So in order to find the root of this function, we are going to consider the capabilities of Excel in locating the root. So before I start, let me just mute everybody. Okay. So we are going to, let me share my Excel screen. So we want to find the root of the function x minus cos x. So like we did in the previous class, we are using graphical method now. So we're going to put in different values of x. Then you're going to evaluate the function at these different values. So in this box, I'm going to type in equal to x is in A2 minus cos A2. So that's the function. So for all the values, we are going to evaluate x minus cos x. So after doing that, we are going to make a plot using the plot function. So this plot is going to help us to know the brackets of the root. So like I told you previously, if we don't know or if we are not giving the brackets, we're going to use graphical method to get the brackets. So this is just what I'm doing. So I'm plotting the function and trying to use graphical method to locate the brackets. Let me just format the axis here. Okay, so we've plotted the function using different values of x, and we got this graph. So, and I told you that the root of the function is where the graph touches the x-axis. So it's touched the x-axis at between 0.7 and 0.8, but we're not sure exactly where. So there's a tool in Excel called the Goal Seek tool. So the Goal Seek tool, we're going to use the Goal Seek tool to actually find the root of x minus cos x. So we've plotted it. We use the graphical approach. So the graphical approach is just to find the estimate. It's just to help us to know the estimate of the root. So we're going to use the Goal Seek function. And for the Goal Seek function, we are going to estimate the root. So we know that the root is between 0.7 and 0.8. So on this box, I'm going to write, let me say 0.71. So this is the estimate. This is the estimated guess. So we want Excel to help us to find the roots exactly. So I've written the estimated guess here. Then on this box, on this cell, I'm going to type in the value of the function. So the value of the function is, now I'm in 826. So 826 minus cos 826. So I'm telling Excel to plot to give me the value of x minus cos x at where x is at cell 826, which I put at 0.71. So when I do that, Excel is going to tell me the value of the function. So I'm going to use Excel now to actually tell me the root of this equation. So in order to use Excel, you go to data on your data tab. Then under your data tab, what if analysis, you click on it. Then you click the goal seek. So you're going to make use of the goal seek Excel function that will help us to get to the root. So when I click the goal seek, it's going to bring up a box. And the box is saying that set cell B26. So this is B26 where my cursor is to 0. Remember, the root of the equation is the value of x when f of x is 0. So this is f of x, which is at B26. We want to set it to 0. We want it to be 0 by changing this cell A26. Then we'll specify cell A26 as A26. So you are telling Excel that this A26 is the estimate. So we use the graphical method to just estimate the root as 0.71 because we know it's between 0.7 and 0.8. So after we did that, we evaluate the function at our estimated guess. And now we are using the goal seek function in Excel to help us calculate the exact root. And the way we do it, that after estimating the value of the function at the particular value of x, you're going to click on the goal seek function, and you are going to tell Excel to set cell B26 to 0 because the root is the value of the function as 0. So you want this B26 to become 0 by changing the value that is in A26. And when we click OK, and automatically Excel will help us to calculate the root of the function. So this was the root that Excel was able to achieve, and this is the value of the function. You know, we said that we should set the value of the function to 0, but Excel was only able to evaluate. When you do this and you evaluate f of x at this value, you are going to get 0.00024. So it's not exactly 0. And since it's not exactly 0, we are going to repeat the goal seek again. So now we know that the root is close to 0.379. So let me change it here to 0.739. Then after that, I would use the goal seek function again. So set cell B26 to 0 by changing cell A26. And when I click OK, it's still giving me a very it's not exactly 0. So let me put 0.74. Remember, this is trial approach. Then I'll call the goal seek. I'll call the goal seek function again. And so set cell B26 to 0. by changing cell A26. Okay, so now the value of the function now is like exponential minus 0.6. So this is the value of the root of x minus cos x. So this value is actually close to 0. So the values we're getting before was 0.0001, something like that. But yeah, there are more zeros. So this value is close to 0. So the conclusion of this is that you can use the goal-seek function in Excel to calculate the value of the root, and you're going to follow the procedure I I went through in order to use Excel. Apart from the goal-seek function, the another way in Excel that you can use to calculate the roots is using the solver. So for instance, if you want to, this is a set of nonlinear simultaneous equation. So you have this function which is equal to 0 and this function. So it's x and y equal to 0, and you want to find the value of x and y. So it's a nonlinear simultaneous equation. I want to use Excel to help us to locate the root. And this is the correct root. X is equal to 2 and y is equal to 3. But we are going to use Excel solver to estimate the value of the root of this simultaneous equation. So we'll use an initial guess of 1 for x and of 3.5 for y. So let's go back to Excel now using the solver. So here is x, here is y, here is u of xy, and here is v of xy. So here we are going to put in our estimated guess. We said that the initial guess for x is 1, the initial guess of y is 3.5. Then we are going to evaluate u of x of y. And remember from the function of u of x of y. Let me go back to the note. The function of u of x of y is x squared plus x multiplied by y minus 10. So we're going to write this equation in Excel. Okay, so u of x of y is equal to, so x squared, so our x is in B1. So I represent x in B1, then y is in B2. So this is the function x squared plus x times y minus 10. And this is the evaluation it gave. Then for v of x comma y, so you're going to evaluate this. So v of x comma y is y plus 3 times x. Okay, there's a question. What influenced your choice of initial? Why not y is equal to 0? So the choice of initial y is just a guess. It's just a guess, like it's just something to start with. So if you want to say you want to start with 0, it's okay. But we are just, for the purpose of this example, we are just saying that our initial guess should be for x to be 1 and for y to be 3.5. So the guess can be anything. So, but we chose this value. So you can also set it to any value, or to 0, like you are pointing out. So this is the function of Vx of y. So Vx of y is y plus 3 times x times y squared minus 57. So that's the function. So we're going to evaluate the function at at that at this particular value. Then you know that we want to this for this u of x of y and v of x of y, we want to drive it to 0. It's supposed to be at 0 because the root is finding the value of the variables when the function is equal to 0. So we want this to be equal to 0, both of these to be equal to 0. So we define another function, and that function is going to be 0 when both this function u and function v is 0. So in mathematics, we normally use the sum of squared. So we are saying that we should square this value here, then square this value here, then add it together. So we know that if this value is 0 and this value is 0, definitely the sum of squared of both of them is going to be 0. And you might ask a question that, because we are defining a function that when this and this is 0, this should be 0. So we are summing the squared, we are squaring the first function, and we are squaring the second function. So let me square it. And we are squaring the second function. And we are saying that this sum of squared is going to be 0 when both this and this is 0. We cannot add it, because if we just say B3, if we have just done this, B3 plus B4, like this value may be negative and this value may be positive, and it's going to give 0. But in actual fact, we want this to be 0 and this to be 0, and the sum of squared to be 0. So we cannot use the summation. So that's why we are making use of the sum of squared. So we are going to use the Excel solver in order to solve for, we want this to be 0 by changing x and y. And what we are going to do is that we're going to use the solver. So this is the solver here. So you just click on it. And if you are using the solver for the very first time, it's not going to be available. So all you need to do is to go to file, then options, then other options. You're going to click on add-ins. So when you click on add-ins, under manage Excel add-ins, then you click on go. So when you click on go, this box is going to come up. So you make sure that solver add-in is checked. And when you check it and click OK, it's going to appear on the data tab or the data ribbon here. So that's the procedure to go through to bring out the solver. And after you've brought out the solver, you just click on it. Then you will say that set the objective function is this. So we said that set this function to a value of 0 because we want the sum of squared to be 0 by changing variable cells B1 and B2. So we are saying that we want Excel to solve this objective function that is in B6, which is the sum of squared. We want to solve it to 0 by changing the values of x and y. So Excel is going to give us the value of x and y when the sum of squared is 0. Then under select a solving method, there are different options. There's GRG, nonlinear, simplex, LP, evolutionary. So you choose the nonlinear because the equations we are trying to solve are nonlinear because it has the squared. So it's a nonlinear. Um, if it's a linear equation, you can choose this, and if it's a non-smooth function, you can choose this. So we are going to use the solving method. Then you click on solve. Then when you click on solve, Excel will find a solution to the problem, and you can choose keep solver solution, and you click OK. So the value of x and y have changed, and this value of u, the function u, and the value of function v, they are almost close to 0. And this function, the sum of square, the objective function, is close to 0. And this is the real value of x that makes that makes the two equations to be 0 are 2 and 3. So we can see that we are actually close to the real value of x and y that solves for the root of this equation. So those are the two features in Excel that you can use to solve for the roots of equations. And there are some times that it might not be possible to find the solver may not be able to solve for the root. So if the solver cannot solve for the root, then you should change your guess. Like a student asks that, why can't we use y is equal to 0? So let's even try that. Let's try y is equal to 0, and let's try x is equal to 1. Or let me put 0 still and see if the Excel solver is able to solve it. So we are going to use the solver, and the parameters are already set, then solve. And can you see the screen that the solver could not find a feasible solution? So there are cases where the solver may not be able to find a solution, just like we have seen. And if the solver is not able to find a solution, that means that your guesses are not very good, they are not appropriate. You should try to change it, and you should try to update it. So let me change it to 1. Let me change this to 2.5, and let me solve it. Okay, so Excel was able to solve it. So you can use the goal-seek function to find the roots of an equation, and you can also use the Excel solver to find the roots of an equation. So we are now going to go into MATLAB. So the functions, we want to see the functions in MATLAB that we can use to solve the roots of an equation. So there are different functions in MATLAB. We have F0, so it's used to get the root of an equation. You can also use roots, and all these functions here, they help in getting the roots of an equation in MATLAB. So we are going to start with the F0 function. So if we want to get the root of this equation in using MATLAB, we're going to use the F0 function. And if you look at this equation, we've been considering this equation in the previous two classes on finding the root. So we want to find the root of this equation using MATLAB. So we use the F0 function. So let me go to MATLAB now. So we want to use the F0 function. So let's bring out the documentation for F0. So if you want to bring out the documentation of any function, you just type help, then F0, and the name of the function. So let's do that. So it's going to tell us what the F0 function is, what is all about, how to pass in parameters into it. So this is the documentation it brought forward. And here it's saying that the F0 can take in two parameters, where the first one is the function, is the function itself, is the f of x, then where x0 is the initial guess. So in this case, x0 is a scalar. So it's saying that x0 can be a scalar. So for this case, if you define it this way, yeah, it's saying that x0 can actually be a vector. So yeah, it can be a scalar, and yeah, it can be a vector. So x0 is the initial guess. So if you just make it a scalar, that means that you are saying that it's just one guess. You're using open method. But if you make it to be a vector, it's going to be a vector of 2. So you can call it this way, you can call it this way, you can call it this way. In this case, you are specifying the options. So we are going to use, we are going to call, so you are going to use, for here there is a third parameter. So in these options, you are trying to say that it should display the procedure it took in finding the root. So let's find the root of that particular equation. So the equation is x raised to power 10 minus 1. So this is x0. x0 is the initial guess. So we are saying that let our initial guess be between 0 and 1.3. So we actually use the initial guess these values of initial guess previously when we were using the bracketing method. Then we are calling the f0 function, and by using this is the function. So when you are expressing a function in MATLAB, you are going to use the at symbol, then the variables that are present in the function. So we only have x here, so we just put x here. So remember that the function is x raised to power 10 minus 1, and this is the initial guess. In this case, is a vector of length 2. So when we click enter, Excel is going to help us to find the value of the root, which is 1. Then this particular function, it has two roots at 1 and minus 1. So this is one root. Then in order to find the root at the other value, because the root of this function is 1 and minus 1. So we would change our guess from 0 to minus 3, and still the same function. So when we do that, it's able to give us the value of the other root, which is minus 1. Then you can also use because when I pulled up the documentation for F0, so here you can use a scalar, you can use a vector. So it takes in two parameters. So you can specify three parameters. So you are going to do just that now. So now we are saying that let the initial guess be 0. We are saying that let the initial guess be 0. Now, the initial guess is a scalar. Previously, it was a vector. So now we are saying it's a scalar because it can actually be a scalar. Then we are specifying three parameters. This is the function, this is the initial guess, and this is the option. So this option is specified here. So what this is saying is that we want to see the iterations as is going on, as Excel is helping us to get the root. We want to see what is going on. And when we click enter, this is what happens. So it's showing us the number of iterations Excel is going through to actually help us to calculate the root. So this is the first, third, some iterations are skipped because of in order not to put in all the iterations. So this is the 24th iteration, and the initial guess was 0. So Excel was just first of all putting 0, evaluate the function, and now it's changed. It's kept on looking. It's using the search method in order to find the root, and it kept on changing it until it got to this point. Then after that, MATLAB changed the procedure it was using. Before, it was using a search method, but later it changed it to interpolation method. I remember we considered the interpolation method. The second method is a linear interpolation method. So after some time, MATLAB started using the interpolation method. Then on the 26th to 28th iteration, it started using the bisection method. So the F0 method uses a combination of different methods in order to get the root. And later, at a later stage, it used the interpolation method. And at the end of the day, it was able to calculate the values of the root at x, which is -1. So this, you can use MATLAB functions in order to get the roots. So the first two lectures we had on roots, you could just say that, okay, you can just use a MATLAB function to do that, but you needed to be aware of the underlying algorithm or the pseudocode behind those methods that these software packages use. And we talked about the bisection method and we talked about the interpolation method. So let me go back to the notes. So you can use MATLAB to find the root of a polynomial expression. For instance, if you want to find the root of this polynomial, this is a fifth order polynomial. I want to use MATLAB to find the root of this polynomial. Definitely, since it's a fifth order polynomial, it's going to have 5 roots, and these are the roots. These are the roots of this polynomial. So in order to do that in MATLAB, you need to specify the coefficient of each of these: x raised to the power 5, x raised to the power 4, x raised to the power 3, x raised to the power 2, x raised to the power 1, and x raised to the power 0. Because here is actually x raised to the power 0. So you're going to specify the coefficients inside a vector. So we said that let the vector be A. So these are the coefficients. So the coefficient of this is 1. So we have 1 here. The coefficient of x raised to the power 4 is -3.5. So we have -3.5 here. The coefficient of x raised to the power 3 is 2.75. So we have 2.75. This is the coefficient. Then the last coefficient is 1.25. So let's go back to MATLAB. So this is the way MATLAB recognizes this polynomial function. You have to specify the coefficients of the polynomial in a vector format. So we are saying that let A be equal to this polynomial, which is a fifth order polynomial. Then in order to there's a MATLAB function called polyval. So polyval will evaluate this polynomial. Remember, we are specifying this polynomial as in vector form. So polyval evaluates this function at x is equal to 1. So if you do this, MATLAB is going to evaluate the function as at x is equal to 1, which is minus 0.25. If I go back to the notes, when we evaluated this function at this polyval is evaluating the function at x is equal to 1. So in place of x, we put in 1. And when we did it by hand, we got minus 0.25. And also when we did it on MATLAB, we also got minus 0.25. So polyval helps us to evaluate the value of a function at a particular value of the variable. Then if we want to differentiate the function, so in the last class, the students asked me that, is there not a function to differentiate, is there not a function in MATLAB that you can differentiate a polynomial? So the poly and DER, so differentiating a polynomial. So this is A. Remember we specify A here. So this is our polynomial. We just specified it using the coefficients. And this is how we do it in MATLAB. So we are telling MATLAB to differentiate this polynomial. And this is the result it's giving us. So it returns the coefficient of the differentiation of the function we specified. And if we go back to the note, when we actually differentiated the function by hand, this is what we got. And if we go back to Excel, if we go back to MATLAB, sorry, this is the same coefficient you get if you differentiate the function by hand that is going to give us. Then if we decide to specify another polynomial, so let me go back to the note. So if we want to specify another polynomial given by this, so remember in MATLAB, and want to store it in B. So in order to specify this polynomial, let's just say we say B is equal to, so we say B is equal to 1. So we'll put it inside a vector 0.5, then minus 0.5. So we are specifying this vector as this polynomial. I remember that this polynomial is one of the roots of the original equation we started with. So this is one root and this is one root. So this polynomial is a root of that equation. So if we go back to MATLAB and specify it, so we are saying that let this be equal to this polynomial. So I'm going to end the meeting now.